Algebra 2, Section 3.1 in our packet, and the title is Graphing Linear Equations if there's two variables. Now there is a section right over here where it's a little bit of an exception. What happens if there's one variable? That's the grand finale. So just to kind of get you warmed up, get you the basics, kind of remind you of things you've done in the past, Algebra 1, pre-algebra, and even before then, let's just talk about, this coordinate plane. So this is a coordinate, this is a coordinate, these are points. But before we even begin, we've got our x-axis. So you've got your positive x there, which means to the right. And you've got your negative x, which means go from the origin. Remember, origin is 0, 0. From there, you go left. That'd be your negative x value. And remember, all coordinates go in the x, y order. So if x is positive, I move to the right. If x is negative, I move to the left. But then my y-axis is right here. That means go down if y is negative, and it means to go up if y is positive. So let's go ahead and practice something. Let's plot this point. Always start from the origin. So we go left 2, because that's my x. 1, 2, and we go up 3. 1, 2, 3. Remember what we're plotting. We're plotting a point, point A. Now let's plot point B. This means in your x direction, go 4. 1, 2, 3, 4. And then because y is negative, we're down 3. 1, 2, 3. And there's my point, point B. Now, this lesson is not how to plot points. It's about how to graph linear equations. Now let's look at the root word, linear. Now we're not talking about ears. We're talking about lines. So ultimately, that's what we're graphing, lines. Now in geometry class, you learned that a line has an infinite number of points on it. So, there's a phrase out there, the shortest distance between any 2 points is a straight line. Now, don't get that confused because there's an infinite number of points along that line. You just need 2 of them to connect to form the line. We're going to talk more about that. So if I was to go like this and connect them back to geometry class, I kind of just did a little bit of a fail because that's a line segment. So to create a line, I need to communicate that I know it never ends in that direction, and I need to communicate that it never ends in that direction. So those little arrows on the end are important. And look at the quadrants. 1, 2, 3, 4. We'll talk about quadrants every now and then. So it starts here, and then it goes counterclockwise. So with that in mind, there's your little review. And now we're going to get into some more details. So first of all, this is about graphing lines, linear equations. So there's one type of way that an equation can be written in linear form. By the way, linear means everything is to the first power. Now what if it's not to the first power? Well, that's a whole different lesson. But because these are ones, we're going to end up with a linear line equation, okay? So if it's written like this, you have a strategy. Knowing that there's an infinite number of points that exist on a line, and you only need minimally 2, start out by grabbing any 2 x's you want. I always like to pick 0, and, let's get crazy and pick a 2. I could have picked a 1 or a 3, but let's start with that. So now I'm going to say, that's just saying plug in x is 0 right here. Well, if I plug in x is 0 right there, it's gone. And then if I divide both sides by 2, I'm going to get y is 3. So my first coordinate point is 0, 3. So that means just go up 3. And there's my first point, 0, 3. But if I plug x is 2 in there, that's literally going like this. And then I have to subtract 2, a little bit of math involved here. 2y equals 4, divide by 2, I'd get y is 2. So there's my second point. I start from the origin, to the right 2, up 2, and then I connect. Now I'm going to teach you something though. If you think your math is perfect, you can go ahead and connect these and call her good. However, if I screwed up on this one or if I screwed up on that one, there's no safety net. There's no way I'm going to know that I screwed one of those up because I'm just going to connect them. So if I grab another X value, this is your safety net. So I like to do 3 here, minimally. Then I plug that in here, plug a 3 in there. Then I subtract 3. I get 2y is 3. Divide by 2, divide by 2. I get y is 3/2, which is just 1.5. And so there's my y value if x is 3. So I go 1, 2, 3. And then I go up 1.5, which would be right about here. And then look at all 3 of them land in the same line, so I know all 3 of them were correct. This is a technique you can use for any graph. If you're ever confused on what does this thing even look like and you forget all your rules, you can make one of these. Just start throwing some x's in, and it's not a bad idea to throw in negative x's either when you get into some pretty complex graphs. But let's move on to this. This is what you're going to resort to way more than this over time. And you guys have been taught this before. Good old y equals mx plus b is called the slope. Where does that come from? The letter m. Remember, m equals slope, and slope equals rise over run. Now rise, if you strictly look at that word in a normal way, if you looked it up in the dictionary, it'd probably be something starting here and going up. The thing is, though, if you go up, that's a positive direction. If you go down, that's a negative direction. So rise doesn't necessarily mean up when you're doing slope. How about run? Run, if you go to the right, that's considered a positive direction. If you go left, that's considered a negative direction. So you've got a lot more going on there than you think. So how do I even use y equals mx plus b? If you notice, this is the same as this. So when I'm done with this, and I graph it here, it should look just like this. Now my drawing's not going to be perfect, but you'll get the idea. So this y equals mx plus b is telling me, hey, get y by itself. So the first thing to get y by itself, I'm going to subtract x from both sides. Now, if I kerchunk these disappear, and I get 2y equals. Now I have a decision to make. Am I going to write this as 6 minus x, or am I going to write it negative x plus 6? Well, because it's mx, I got to put my slope and my x first, so that's going to be negative x, and then here's my b, because b is a constant, plus 6. Now, am I done yet? No. So I could divide by 2, divide by 2, divide by 2. But to just make this understood, slope always needs to be a fraction. So instead of dividing by 2, I'm going to multiply this by 1/2 because it's just going to help me understand y equals mx plus b better. So if I distribute, I'm going to get y equals, now watch this, negative 1/2 x plus 3. Now, what is b? B is my y-intercept, and that's where the line crosses the y-axis. Now remember, we had 0, 3 over here, and this is the same equation as this. Well, over here, this is my y-intercept, and I'm going to do that first, and that means I'm going to find the y-axis, and I'm going to go up 3. Then, I'm going to move slope. Now notice where my negative is. It's with my numerator, which is my rise. And if my numerator is negative, that means I go down 1. So right here, don't put a dot there because I'm not done yet. And then I go over or run 2. And if 2 is positive, I go to the right. 1, 2. And then I connect the dots. I missed that one, but. So, you can see this line is the same as this. Now this is a little bit bigger, so it looks a little different, but they're the same. Now what's the advantage of this? The advantage of this is you're going to get very accurate because you got points and points and points, and you're going to have a safety net. This one, you don't really have a safety net, but it's faster. And okay, so there's your first example of rise over run. Now a lot of students ask, what if I accidentally put the negative in front? What do I do with it then? Well, technically that negative can go with the 1, but it can also go with the 2. So let's say a different student put it with the 2. Remember, the first thing you do is you find your y-intercept, which is right here. So let's say we now have 1 over negative 2. That means this is my rise, so I go up 1, but now I would have to go left 2 because it's negative, 1, 2, and it would give me this other point, not this one, but it would still give me the same line once I connect the dots. Now, the title of this lesson is graphing linear equations with 2 variables, but there are a couple homework problems where there's only 1 variable. These are so easy, they're hard, and it's just confusing. If it says x equals 2, and that's all it is, you're not going to put it in y equals mx plus b. This is not even possible to put in standard form because you've lost your y. What this is saying is x can't be anything but 2. And if I plug this in, what does that mean y is? Well, it can be anything. And if I actually graphed that, and I graphed all these points, 1, 2, 1, 1, 2, 2, 1, 2, 3, and this is just 2 comma 4, that's all we're doing. 2 comma 4, you can see something very unique about this line. It's a vertical line. And here's a hint. Notice the equation is x equals 2, and it crosses the x-axis right at 2, so it's got to be a vertical line. This one's similar, but notice I've messed it up a little bit. I didn't make it quite as easy, so you have to actually subtract 1 and go y equals negative 1. What this means is, on this little barbaric graph, y can't be anything but negative 1. So what is x? Well, x can be anything. So I'm just going to pick 2, 3, and 4. Now I'm going to plot these points. That's 2 comma negative 1, so from the origin 1, 2, then down 1. To the right 3, down 1. To the right 4, down 1. And you can see this is a horizontal. That's y equals negative 1. Notice it crosses the y-axis. By the way, not to be confused with, that's my x-axis. I should have used a different color. But this is a horizontal line that crosses the y-axis. And notice what it says, y equals negative 1. There's your little clue. There is your pre-lesson.